Hello. On this video we're going to be talking about valence electrons and how to find them. So we said that valence electrons were the electrons that are in the highest energy level. So when we're doing our electron configurations like we did in the last video, if you remember, this block right here, or what we called our D block, started at the third energy level. Even though it starts in the fourth row, started at the third energy level. And likewise, this block down here, our F block, I said starts at the fourth energy level, even though our F elements start right in this gap right here. They start right in that gap, except they're on the fourth energy level, even though they're in the sixth row. So those electrons that are in the D and F orbital blocks do not count towards valence electrons. So our question is, what does count towards valence electrons? Which, all the columns that are in the S or P orbitals will count towards valence electrons, which means that we can have a maximum of 8 valence electrons. So these are very easy to find. In our activities that we did and things we saw, that anything that's in this first row of the periodic table has 1 valence electron. And you can label your periodic table with this if you want to. That first row has 1 valence electron. Our second row has 2 valence electrons. But this is where it gets a little bit tricky, because what about our little friend helium over here? In the first energy level, remember that it only gets 2 electrons in it. In this column over here, since it's at the end of the periodic table, you would think it has 8 valence electrons. But helium doesn't get 8 valence electrons because it kind of belongs in a box right here next to hydrogen. So we can kind of draw in helium there. And helium goes in that box. So helium will get 2 valence electrons, even though everything else in that row has 8. So we can kind of forget about helium being over here when we're talking about valence electrons. It really belongs over in that second column with the rest of the elements that have 2 valence electrons. So remember, we skipped this D block here. So above boron, we'll have 3 valence electrons. Carbon's column, will have 4. Nitrogen's column will have 5. Oxygen's column has 6. And fluorine's column has 7. So when we're looking for valence electrons, if I said how many are in carbon, you would look, see it's in the column with 4, so you'd say carbon has 4. If I said how many valence electrons does ununoctium have, which is way down here, you would say, oh, it's in the column that has 8 valence electrons, so it must have 8 valence electrons. So it's very simple to find those. The thing that gets a little difficult is if you try and look into the D or F blocks to find valence electrons. So let's say I wanted to know how many are in zirconium, which zirconium is right here. And remember, we said the D block doesn't gain any valence electrons. So how many would you have? Well, if you started in the 5th row at rubidium right here, and you kept moving to the right, you would go from 1 valence electron to 2, and then when you moved over to yttrium, you wouldn't gain any more, so you'd still have 2 valence electrons, and then when you go over to zirconium, same thing, still 2 valence electrons. And it's that way until you get all the way over here to cadmium in that row, still has 2 valence electrons, and then when you move over to indium, that's when you get to 3, because indium is in that column that has 3. Same thing with the F block. So if we were to choose, let's say, uranium, everyone's favorite radioactive element, uranium comes in this gap between barium and what is that, lutetium or lutetium? There. So in that gap, you get into the lanthanide series, starting with lanthanum. And then the next row down, you have radium and lawrencium. In between there, you start the actinide series, starting with actium over here. So when you're in this 7th row, you go from 1 valence electron to 2. Then you go from 2, and we skip down into this row. We still have 2. We still have 2. We still have 2. And we still have 2. And you can keep going all the way across here, and then from there it loops back around here and goes all the way across. Those all still have 2, and then you come over here, and now this is when you get your third. So those blocks can be a little bit weird, but otherwise you just follow what's in the column that you're in, and that'll tell you valence electrons.